Section 2.4 is on relations and functions. And we need to know some definitions to go through this section. Never would I test on a definition, but I'm going to use words and just having a little context to what the word means is going to probably be helpful. So the first word I wrote a definition for is a relation. And a relation is just a set or group of ordered pairs, kind of in the form of points when we get to graphing. So a typical relation is a set of ordered pairs, and usually I give relations capital letter names, and I enclose the ordered pairs in little squiggly set braces. But I might say this is an example of a relation. It has the ordered pair 1, 2. 1 is usually an x, 2 would be a y. 3, 4, I'm just randomly making up numbers, not usually using much thought. 5, 6, and 7, 8. So this is a relation that has 4 ordered pairs. I'd probably call these ordered pairs points because they look like what we're going to know as points pretty quickly here. For this relation that I made up, the domain is a feature of all relations. The domain is all the x values in the ordered pairs that make up the relation. So for this relation that I just made up, the domain in the same squiggly set braces are going to be the x coordinates, and each one of these ordered pairs, the first value is going to be an x, the second value is going to be a y. And for the relation that I just created here, the domain would be 1, 3, 5, and 7. And then it says the range of a relation is the y values in the ordered pairs that make up the relation. So for this random relation that just has 4 points that I randomly made up, the range of this relation is 2, 4, 6, and 8, the 4 y values. In the world of relations, there's 2 kinds of relations. There's a relation that's a function and a relation that's not a function. A relation is not a function if any 2 points have the same x values with different y values. A relation is a function if no points have the same x values with different y values. When I look at the relation I made up here, there were no 2 points that had the same x values with different y values. So this relation is one of the 2 kinds. This is the relation that's an example of a function, because it doesn't have duplicate x's. It's super common when I create a relation, if it's ordered pairs in the form x first and y second. If the relation is a function because it doesn't have duplicate x's, we usually say that y is a function of x. So for this relation, it had 4 ordered pairs. The domain is the set containing 1, 3, 5, and 7. The range is the set containing 2, 4, 6, and 8. This relation is a relation that's an example of a function because I don't have duplicate x's. And because the points are in the form x and y, we can say y is a function of x. Let me make up another relation. So this is kind of my first working relation, and I'll make a second one, define it similarly. I don't know if I'm going to make more or less points. Maybe I'll make more points. This is considered a finite relation because I'm able to list all the points. We have infinite relations that have infinitely many points. Let me make up new points. How about 0, 5, 1, 10, 0, 15, 2, 20, 3, 25. So this is just another relation, and I want to list the domain of this relation. It's a finite relation. It's easy enough to pick off all the x values. I'm just going to look at the x values I created, and I'm going to write them in ascending order even though that's not necessary. And If I have a duplicate x value, I only need to write it once. So I'd say the domain for this relation is 0, 1. Don't need to include that 0 because I already have a 0, 2, and 3. And then I also want to write the range of this relation. The range of this relation is the y's, and I'm just going to write them in order. So ascending order. The first y is 5 because the points are x first and y second. Second y is 10. Third y is 15. Fourth y is 20. Last y is 25. So I gave you a relation. I always, if I can list the points that make up a relation, it's super easy to list the domain and the range. There's two kinds of relations. There's relations that are functions, where each of the x's are different. And there's a relation that's not a function. A relation's not a function if there's any points that have the same x value with different y values. And this relation that I just created, this is an example of a relation that's not a function. This is a relation that is not a function. Because I have 2 points with the same x with different y's. So we couldn't say y is a function of x. I guess if I wanted to, I could say y is not a function of x. Because this is not a function. I actually took a lot of my math at GCC, well, in the 80s, and when I got hired, you know, a handful of my teachers were still teaching there, which was really cool for them and cool for me. But honestly, I would consistently get, you know, if not the high score, right up close to the high score. And when I got into grad school, I found out how lazy I was. I just kind of studied for the test, and I didn't really take the time to learn and understand. And my knowledge of function notation when I got into grad school was like, you know, embarrassing. I didn't understand functions at all, and it turned out in grad school it was really important. So I had to really teach myself up real quickly, and it definitely caused a lot of pain. This is an important topic, functions, domains and range functions. Not so much relations, but relations that are functions. It's a big deal. And we need to get, you know, real familiar and comfortable with the concepts, because it'll come up a lot in our class, and it keeps coming up in every math class if you need to go higher. So let me just jump into the homework now. The first 4 problems give us a relation that's defined pictorially, and I'm asked to create the points implied by the relation. This is super easy to do. You'll notice that I have an x column and a y column with arrows going from each x to a y in some double arrows. So I'm going to just create the points implied by the relation just by following the arrows. So this relation, the first point I'm going to write is 1 comma a, because there's an arrow going from 1 to a. And then I'm going to write 2 comma d, because there's an arrow going from 2 to d. And then I'm going to get 2 more points, 3b and 3c. And I'm out of room here, so rather than going off the screen, I'll just make this a funky looking relation. Maybe I give the relation a name, but I don't really have to. So that's part A for number 2. That's creating them points implied by the relation. Now I'm going to separately for part B find the domain and the range. And that's real easy to do. The domains are the x's, the 1, 2, and 3. I don't need to write the 3 twice. And I'm going to write the domain in those same squiggly, curly braces, I think they're called. And the range is the y's, and I'll write the letters alphabetically. Instead of A, D, C, B, which would be fine. You don't need to write the range alphabetically if it's variables or letters. I don't need to write the domain with the numbers in any sort of increasing order, but it just feels good to do that. There's no reason not to do it, and it makes it easier, for me to make sure your test question is right if this is a test question. And then part C, this is a relation because I can write it as a set of points. Is y a function of x? And for part C, because I have 2 points with the same x but different y's, I'm going to say y is not a function of x. The field of the concept of function is a monster field, and you might have learned way more about functions in high school than we're going to do in our class, and this is completely fine. We'll do what you need for our class and kind of what you need for college algebra, but we're really lightly going to scuff the surface of the idea of functions. I can barely read 4, so I'm going to do 3 with you. The font's pushing my eyes, and on the screen is still pushing my eyes. So 3, part A, wants me to list the points implied by the arrows in the relation. And this is nice, they're just straight. I don't know these little dots here. I stole this off of Google Images because I guess I could have made something on my iPad, but it wouldn't have looked this nice. And because it was easy enough just to search function or search relation using Google Images, I just stole this and didn't look like it was copyrighted. So that's it for 3A. That's the points implied by the relation. And the domain would be the x values. The x values are just 1, 2, 3, and 4. They're easier to see there right under the letter x. Should probably say I'm doing 3B. And the range is going to be the y's. And I'm going to write them A, B, C, D alphabetically, but you don't have to. And then for 3C, is y a function of x? The answer here is going to be yes, because there's no 2 points that have the same x. So here it's going to be y is a function of x. Y is not a function of x if there's duplicate x's among the points in the relation. Y is a function of x if all the points have different x's. The next few problems we start getting into graphs. We really haven't done graphs yet, but I'm assuming you're a little bit familiar with graphs. This is called a Cartesian coordinate system, and the horizontal direction is the x direction. The vertical direction is the y direction. This point 6, 5, to get to it, I'd start at the spot called the origin, which is the point 0, 0, and I'd go right 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5. So the points are listed relative to the where the lines meet, where the x-axis and y-axis meet. That's not important right now. We just need to be able to find the domain and range from this relation. Super easy to do. I see the points, so I know all the points in the relation. I'm going to do 6. So save you number 5. To do 6A, to list the domain of this relation, the relation has these 1, 2, 3, 4 points. The domain of this relation is going to have the -5, the x coordinate of that point, the 2, the x coordinate of that point, the 4 and the 7, the x coordinates of the other points, and the range are going to be the y's, and I go from low to high, so I'm going to take that y of 1, that y of 3, that y of 4, and that y of 6. So now I just need to answer part B as y a function of x. If I look at the points, The x's are all different. Because all 4 x's of the points are different, I don't have 2 points with the same x, then y is a function of x. I'm checking to make sure I haven't said anything, made a mistake, because I hate to leave a mistake early in the video, then I re-record the whole video when that happens, and I'm feeling okay about that, so that wasn't the reason for the pause right there, was just me checking. Hopefully this shows, let me try to autofocus this, it's just not feeling as crisp as it should be, but kind of is what it is. So I'm going to work through the problem 8. Exactly the same questions. So I'm going to, for part A on number 8, I'm going to list the domain, and this is where I'm going to get my issue. Here there's 2 different points with a -5. When I go to answer part B, it's not going to be a function. But when I go to list the domain, that doesn't matter whether it's a function or not. So -5 from those points 0, 1, and 3 are the x values of the points, so that's going to be my domain. I should probably write domain or D next to it so I can understand that that's what I've just written. The range is going to be the y values. -3, both of those have a y of 2. I don't need to write the 2 twice. And then 4 and 6. That's the end of part A. Part B, determine whether y is a function of x. I'll say y is not a function of x because those 2 points have the same x. And that's the only thing that keeps a function y from being a function of x. If all the x's are different, then y is a function of x. You have duplicate x's, then it's not. The next thing we need to worry about is function notation. And in the world of this section, or for the rest of the class, this mouse pad was showing up. These were my dogs, Kate and Oswald. Oh gosh, must be 15 years ago. And it was like an 8-year-old girl at the time, so she's older than you guys, for what that's worth. This was just showing up and looked so strange to see that. Anyways, somebody made that as a gift for me, and I had it forever. Anyways, function notation, big deal, not so complicated. Function notation, when I see a lowercase letter, usually the letter F, but sometimes the letter G, sometimes the letter H, sometimes the letter K, followed by a parentheses, this is usually function notation. And inside the parentheses can be anything. This is considered function notation, and I read this, at least I read this, as f of x, or the value of f at x. So this right here, this top one, I would either read f of x, or the value of f at x. Mathematicians, they've done things that bother me, and this is a big one, because they're using a notation that we already use for something else differently. Usually if I had something that looks like this, I would think that's f times x, and that parentheses means times. That's not the case here. This does not mean times. This f of x does not mean multiplication. This doesn't mean f times x. It looks like it does, but it doesn't. So it is like a dual meaning. in some sense. We might, in the world of not functions, then that would be multiplication. But we're in the world of functions. This does not mean multiplication. I made some little bullet points to remember what to say. So this function right here, its name is f. The letter in the parentheses is the domain value. It's the number we're going to put in. We're going to put in a number from x. A function is like a machine. You put a number for x in, you get a number for y out. The numbers that you plug into the function, the x's, we call inputs or domains. I call them domains, but input is kind of a more elementary word that you'll hear. And when I plug a number into a function or evaluate a function at a value for x, usually what I get out is a y. It's the range. So the domain, I put a number in for the domain and I get out a number for the range. This all doesn't make too much sense until we get into more physical examples. But anyways, we'll keep plodding along here. It says the range of a function consists all of the possible y's that can be generated from all the x's. That's just too many words right now. Let's just try to get used to the symbols a little bit and not get too deep into it, but deep enough so that we can get the understanding that we need. And here it says the variable y and the function f of x symbol are usually interchangeable. If I see a problem with a function notation, I could probably erase the function notation, put a y in its place, and it will have the same meaning. So this symbol, I read this as y is f of x, or y equals the value of f evaluated at x. The x's are the inputs or the domains. When I put a value into a function, what I get out is a range. So I wrote a more specific example here. I created a specific function. I read this as the function f of x equals 2x. And the function is named x. The letter or variable in the parentheses is the domain. And when I put in a value for x, I get out a y when I multiply that x by 2. So let me show you how this works. If I just take a random number and I say evaluate the function, when x equals to 3, I just randomly made up the number 3 because I could do the math in my head, I would write this down. If I want you to change the x to 3, I change the x in the parentheses to 3, and to the right of the equal sign, I change the x to 3. So if I evaluate this function when x equals 3, I'm going to get 6. What I do when I plug a number in for x, I get a y. This right here is actually creating the ordered pair 3, 6. The 3 would be part of the domain of this function. 6 would be part of the range. So numbers in parentheses, I usually think of as x's. Values that I get out, I usually think of as y's. I think that's enough here. I'm thumbing through. I typed so much stuff up that I think I can just jump into the questions. We're at 24 minutes. Let's go for a few more minutes and let's work with function notations a little bit. So I've created a function that's just a relation written as a set of ordered pairs that isn't written with function notation, but I have function notation in my question, so I wanted to expose us to that function notation because it's going to be relevant. So problems 9 and 10 are similar problems. They give us a relation that's a function. They first want me to find the domain, and I know how to find the domain from a function or the domain from a relation. The domain of this is just going to be the x's, and I'll write them in order. -4 is the smallest value. Negative 3 is the second smallest. 1 is the third smallest. Then 2, then 5, then 6. All of the x's are different. That makes this relation a function. Part D wants me to find the range. And the range is just the y. So I see negative 3, negative 3, 2, negative 2, 5, and 7. That's going to be the range. I'm going to write these in order. So the negative 3 there's 2 of them. I only need to write one of them. That's the smallest number. I'll write it first. I'm going to write the negative 2 second, then the 2, and then the 5, and then the 7. I'm just writing each of the y's in ascending order. Now we get to the function notation. This question right here, f parentheses 2, this is asking me, this in a quick way, it's asking me to find, because numbers inside parentheses are x's, it's asking me to find a y when the x is 2. So it's asking me to find the y coordinate of the point that has an x equal to 2, because in function notation that doesn't mean multiply, it means f evaluated at 2. It means f evaluated when x equals to 2. And this question C is very specifically calling out this point. Question 10C gives me the value of 2 inside of parentheses, and in function notations, numbers in parentheses stand for x's. And when I plug a number in for x, I get a number out for y. The y here is going to be negative 3. Question D is written similarly, except the number in the parentheses is changed. And so it's asking this essentially the same question. It's asking me to find the y coordinate, I'll abbreviate that, of the point maybe. There, maybe could have wrote or the point that has x equal to 5. So this is getting to be really important because understanding function notation is a big deal. Part D is calling out the point 5, negative 2. And I'm going to give you the negative 2 for the answer. So always when I'm exposed to function notation, if I'm given function notation, the number in the parentheses is going to represent an x unless the function doesn't represent x's and y's. But for now, we're just going to consider parentheses, functions, numbers in parentheses are x's, and the function notation, if I'm given a number in a parentheses and I'm asked to do some algebra, I'm going to find the y. The next two questions are the reverse of this. It's asking me in part E to find all values of x such that f of x is equal to negative 3. Real specifically, numbers to the right of the equal sign in function notations are y's. When I did my last little scribble problem and I plugged 3 in and got 6 out, the 3 was an x, the 6 was a y. Numbers inside function notations parentheses are x's. Numbers to the right of the equal sign when we're living in the world of function notation is a y. So question E for part 10, it says find the values of x such that y is equal to negative 3 in some sense. Here, I'm going to try to find the x coordinate of any point that has negative 3 for its y. Because in function notation, numbers inside parentheses are x's, numbers to the right of the equal signs are y. Since I'm giving a number to the right of the equal sign, I have a y. And when I go to answer this question, I have to be careful because sometimes there's going to be duplicates, and that's the case here. part E of number 10 calls out both of those points because both of those points have -3 for the y's. My answer to part E would be x equal to 1 and x equal to 2. Question F is asking essentially the same question as E, except it's looking for the x coordinate of any point that has a 2 for the y, and F is calling out that point. So my answer for part F is going to be x equal to 2. I think I want to do one more problem and then we'll start to a new part of the video because these are essentially duplicate problems. So let's go through number 12 together, then we'll pause and do a part 2, which I think is not going to be horribly long, but there's important stuff in it. So for 12, it gives me a function that's called g. G is a common name for a function. F and G are probably the most common names for functions. 12a wants me to find the domain of this. I'm going to be lazy because the video is getting long, and it's okay when you're defining the domain in a range of a function if the function is just a set of a finite number of points. You don't have to write the domain in ascending order. You don't have to write the range in ascending order. I prefer it, but it's not crucial. And for the range, I wrote that y of -3, that y of 2. I didn't include that -3 because I already had it. I didn't include that 2 because I already had it, and then I did the 1. So my range is actually in ascending order. My domain wasn't. Part C wants me to find the y coordinate when x equals to 1, because when function notation, numbers in parentheses are x's. And so 12c gives me the point 1, 2. My answer to 12c is just going to be g of 1 equals to 2. For part D, the number in a parentheses, that -3 is an x. It wants me to find the y that corresponds to x equal -3. And the point that is calling out in 12 is the point -3, 2. The answer is going to be 2 again. The next two questions, the value they give me are y's, and I want to find the x. In part E, the value that's given in the questions to the right of an equal sign, in function notation, when you're given a question in the form that tells me to find the values of x such that g of x equals -3. In function notation, if the number given is inside a parentheses, it stands for an x. You're asked to find a y. In function notation, if the number that's provided to you is to the right of the equal sign, it stands for a y. You need to find the x. I highlighted the values I need here. I went up and I searched for the y's, and I found two y's that had -3. So my answer to part E would be x equal to 5 and x equal to 2. For part F, find all values of x such that g of x equals to 1. I'm looking very specifically at the y coordinates of my points. I'm trying to find the one that has y equal to 1, and there's only one point that has y equal to 1. This is the point that I need for 12F, and its x coordinate is 6. So we're 34 minutes into this, so I'm going to pause the video. We'll do a part 2. The next few problems are going to feel just like this, so it's going to be probably, if these feel good, it's going to be a smooth transition to part 2.